Hibernate Architecture. Here you can see a comprehensive architecture. The comprehensive architecture abstracts the application away from the underlying JDBC, JTA APIs and allows Hibernate to manage the details. Hibernate ORM, or simply Hibernate, is an object relational mapping tool for the Java programming language. It provides a framework for mapping an object-oriented domain model to a relational database. Hibernate handles object relational impedance mismatch problems by replacing direct persistent database accesses with high-level object handling functions. Here you can see a high-level view of the Hibernate architecture. Here you can see application, persistent objects. You can see Hibernate, Hibernate.properties and XML mappings are in Hibernate and database. Here we do not have the scope to provide more details view of all the runtime architectures available. Hibernate is flexible and supports several different approaches. We will, however, show the two extremes: minimal architecture and comprehensive architecture. Here you can see the minimal architecture. This diagram illustrates how Hibernate utilizes database and configuration data to provide persistent services and persistent objects to the application. The minimal architecture has the application provide its own JDBC connections and manage its own transactions. This approach uses a minimal subset of Hibernate's APIs. Here you can see application. Transient objects are in application. You can see persistent objects and SessionFactory, Session, JDBC, JNDI, JTA, and below database. Here you can see a comprehensive architecture. The comprehensive architecture abstracts the application away from the underlying JDBC, JTA APIs and allow Hibernate to manage the details. Now we are focusing on application. Application software is programs designed to handle specific tasks for users. Smartphone apps became a common way for individuals to access information systems. Other examples include general purpose application suites with their spreadsheet and word processing programs, as well as vertical applications that serve a specific industry segment. For instance, an application that schedules routes and tracks package deliveries for an overnight carrier. Larger firms use licensed applications developed and maintained by specialized software companies, customizing them to meet their specific needs, and develop other applications in-house or on an outsourced basis. Companies may also use applications delivered as software as a service SaaS from the clouds over the web. Proprietary software available from and supported by its vendors is being challenged by open source software available on the web for free use and modification under a license that protects its future availability. Here you can see Spring MVC plus Spring Data JPA plus Hibernate, crude example here. Now we are focusing on transient objects. An object is transient if it has just been instantiated using the new operator and it is not associated with a Hibernate session. It has no persistent representation in the database and no identifier value has been assigned. Transient instances will be destroyed by the garbage collector if the application does not hold a reference anymore. Use the Hibernate session to make an object persistent and let Hibernate take care of the SQL statements that need to be executed for this transaction. Here you can see changing new objects to transient state. Transient state is the first state of an entity object. When we instantiate an object of Pojo class using a new operator, then the object is in the transient state. This object is not connected with any Hibernate session. As it is not connected to any Hibernate session, so this state is not connected to any database table. So if we make any changes in the data of the Pojo class, then the database table is not altered. Transient objects are independent of Hibernate and they exist in the heap memory. There are two layouts in which transient state will occur as follows. One, when objects are generated by an application but are not connected to any session. The objects are generated by a closed session. As an example, you can see this code segment. Here we are creating a new object for the employee class. Here is the code which shows initialization of employee object. Here the object's state. As an exception example, we can consider transient object exception thrown when the user passes a transient instance to a session method that expects a persistent instance. This exception is in org.hibernate package. As an error example, we can consider this object references an unsaved transient state, unsaved transient instance. Now we are focusing on persistent objects. A persistent instance has a representation in the database and an identifier value. It might just have been saved or loaded. However, it is by definition in the scope of a session. Hibernate will detect any changes made to an object in persistent state and synchronize the state with the database when the unit of work completes. Developers do not execute manual update statements or delete statements when an object should be made transient. Here you can see Hibernate life cycle. Here we will talk about Hibernate life cycle, or in other words, we can say that we can talk about the life cycle of the mapped instances of the entity object classes in Hibernate. In Hibernate, we can either create a new object of an entity and store it into the database, or we can fetch the existing data of an entity from the database. This entity is connected with the life cycle, and each object of entity passes through the various stages of the life cycle. There are mainly 4 states of the Hibernate life cycle: transient state, persistent state, detached state, removed state. The transient state is the first state of an entity object. When we instantiate an object of Pojo class using the new operator, then the object is in the transient state. This object is not connected with any Hibernate session. As it is not connected to any Hibernate session, so this state is not connected to any database table. So if we make any changes in the data of the Pojo class, then the database table is not altered. Transient objects are independent of Hibernate and they exist in the heap memory. There are 2 layouts in which transient state will occur as follows. 1. When objects are generated by an application but are not connected to any session. 2. The objects are generated by a closed session. Persistent state. Once an object is connected with the Hibernate session, then the object moves into the persistent state. So there are 2 ways to convert the transient state to the persistent state. 1. Using Hibernate session, save the entity object into the database table. 2. Using the Hibernate session, load the entity object into the database table. Following are the methods given for the persistent state. Session.persist, session.save, session.save or update, session.merge, session.lock. detached state. For converting an object from persistent state to detached state, we either have to close the session or we have to clear its cache. As the session is closed here or the cache is cleared, then any changes made to the data will not affect the database table. Whenever needed, the detached object can be reconnected to a new Hibernate session. To reconnect the detached object to a new Hibernate session, we will use following methods as follows: merge, update, load, refresh, save, following are the methods used for the detached state: session.detach, session.evict, session.clear, session.close. Removed state. In Hibernate lifecycle, it is last state. The removed state when the entity object is deleted from the database, then the entity object is known to be in the removed state. It is done by calling delete operation. As the entity object is in the removed state, if any change will be done in the data will not affect the database table. Note, to make a removed entity object, we will call session.delete method. Here you can see a new instance of entities passed to transient state. Garbage is passed from transient state. Transient state is connected to persistent state. Save, persist, and save or update and update methods are passed from transient state to persistent state. Get and load methods are passed to transient state. Transient state is connected to removed state. Delete method is passed from transient state to removed state, and removed state is there. Garbage is from removed state, and transient state interacts with detached state. Detach, close, clear, and evict methods are passed from transient state to detached state. Save or update, merge, and lock methods are from detached state to persistent state. Garbage is from detached state. Here you can see converting transient state to persistent state. Here you can see using the Hibernate session, the save entity object into the database table. Here you can see using the Hibernate session, load entity object into the database table. Here transient state is connected to persistent state. Save, persist, save or update, and update methods are from transient state to persistent state. And here database is connected to persistent state. Get and load methods are from database to persistent state. As an example, we can consider this code segment. Newly instantiated instances of a persistent classes are considered transient by Hibernate. We can make Hibernate instance persistent by associating it with the session. If cat has a generated identifier, the identifier is generated and assigned to the cat when save is called. If cat has an assigned identifier or composite key, the identifier should be assigned to the cat instance before calling save. You can also use persist instead of save with the semantic defined in the EGB3 early draft. Persist method makes a transient instance persistent. However, it does not guarantee that identifier value will be assigned to the persist instance immediately. The assignment might happen at flush time. Persist method also guaranteed that it will not execute an insert statement if it is called outside the transaction boundaries. This is useful in long-running conversations with an extended session persistent context. Save does guarantee to return an identifier. If an insert has to be executed to get the identifier, for example, identity generator, not sequence, this insert happens immediately, no matter if you are inside or outside of a transaction. This is problematic in a long-running conversation with an extended session persistence context. Here you can see a save object, persist. Here you can see a save method, persist the given transient instant, first assigning a generated identifier or using the current value of the identifier property if the assigned generator is used. This operation cascades to associated instances if the association is mapped with cascade equals save update. This method is in org.hibernate.session interface. Here you can see an example of mapping. A table lets you to define the table entity will be persisted into. If undefined, the table name is the unqualified class name of the entity. You can also optionally define the catalog, the schema, as well as unique constraints on the table. The constraints name is optional, generated if left undefined. The column names corresponding the column names composing the constraint correspond to column names as defined before the Hibernate naming strategy is applied. and you can see here column names. Here you can see an example of mapping in file hbm.xml. As an example, we can consider class persistent object exception thrown when the user passes a persistent instance to a session method that expects a transient instant. This class is in org.hibernate package. As an error example, we can consider this detach entity pass to the persist com.bwt.spindle.model.plot. Now we are focusing on SessionFactory. The main contract here is the creation of session instances. Usually an application has a single SessionFactory instance, and threads servicing client requests obtain sessions instances from this factory. The internal state of a SessionFactory is immutable. Once it is created, this internal state is set. This internal state includes all of the metadata about object relational mapping. Implementers must be thread safe. Here you can see SessionFactory and session in Hibernate. SessionFactory is an interface available in org.hibernate package, which extends referenceable and serializable interface and provide factory methods to get session object. Let's see some points about this SessionFactory. SessionFactory is thread safe, so multiple threads can access SessionFactory at the same time. SessionFactory is immutable. Once we create SessionFactory, we can not modify it. If you look SessionFactory methods, we don't have any setter kind of method. SessionFactory is created at the time of application startup. It reads all information from the configurable file. Hibernate.cfg.xml file. We should have one SessionFactory for one database configuration. We can create SessionFactory object using configuration class. Here first we are creating configuration class object and call configure method. Which has two overloaded versions, one without parameter like configure method, and another one is configure string resources. If we use configure without parameters method, hibernate.cfg.xml is defined. Session is an interface available in org.hibernate package, which provide different API to communicate Java application to Hibernate. Let's see some points related to session. The session is not thread safe. The main use of the session object to perform create, get and delete operations for Java classes entity. the first level cache belongs to the session object. We can have multiple sessions for a session factory. We can get session object using SessionFactory reference. As here. Here you can see configuration. You can see the code here. Configuration config equal new configuration dot configure, and configuration is connected to SessionFactory. You can see config.build SessionFactory method here to get a SessionFactory object, and SessionFactory is connected to session. You can see factory dot open session method to get a session here. As an example, we can consider this code segment, and here you can see the interface SessionFactory. The main contract here is the creation of session interfaces. Usually an application has a single SessionFactory instance, and thread serving client request obtain session instances from this factory. This interface is in org.hibernate package. Here you can see build SessionFactory method is called. Here you can see the XML configuration file is by default expected to be in the root of your class path. Here's an example here. The file is hibernate.config.xml here, and here you can see a SessionFactory instance listed as /JNDI /name, SessionFactory name, this one. We can see properties here and mapped files here and cache settings here. As an example, we can consider as an exception example, we can consider Hibernate exception. This indicates a problem opening the session, pretty rare here. For example, this exception can occur in open session method in interface SessionFactory. As an error example, we can consider this one. The content of element type SessionFactory must match property mapping class cache collection cache event listener. Now we are focusing on TransactionFactory. Contract for generating Hibernate transaction instances. The concrete implementation to be used is specified by the environment.transaction_strategy configuration setting. Implementers must be thread safe and should declare a public default constructor. We can consider this as an example. Here get TransactionFactory produces TransactionFactory. The interface TransactionFactory is a contract for generating Hibernate transaction instances. It's in package org.hibernate.transaction. Here the variable owner is context. As an example too, we can consider this one. This is in hibernate.cfg.xml file, and here you can see Hibernate transaction property transaction.factory underscore class. The class name of a transaction factory to use with Hibernate transaction API, default to JDBC transaction factory. For example, class name dot of transaction factory. As an exception example, we can consider Hibernate exception. Indicates a problem generating a transaction instance. This exception can be occurred in method transaction, create transaction, JDBC context, TransactionFactory.context method in interface transaction factory. Now we are focusing on ConnectionProvider, a strategy for obtaining JDBC connections. Implementers might also implement connection pooling. The ConnectionProvider interface is not intended to be exposed to the application. Instead, it is used internally by Hibernate to obtain connections. Implementers should provide a public default constructor. As an example, we can consider this code segment. Interface ConnectionProvider, a strategy for obtaining JDBC connections. This is in package org.hibernate.connection. As an example too, we can consider this segment in hibernate.cfg.xml file. Here you can see Hibernate, JDBC and connection property hibernate.connection.provider underscore class. The class name of a custom org.hibernate.connection.connection provider, which provide JDBC connection to the Hibernate. For example, class name of connection provider. Here 3C here C3PO, a Java library that provides a convenient way for managing database connections. As an example, we can consider SQL exception, which can be occurred in connection get connection method in interface ConnectionProvider. As an error example, we can consider this one, java.lang.no class definition found error org/hibernate/connection/connection provider. This occurred in Hibernate 4. Now we are focusing on session, the main runtime interface between Java application and Hibernate. This is the central API class abstracting the notion of a persistence service. The life cycle of a session is bounded by the beginning and end of a logical transaction. Long transactions might span several database transactions. The main function of the session is to offer create, read, and delete operations for instances of mapped entity classes. Instances may exist in one of three states: transient, never persistent, not associated with any session; persistent, associated with a unique session; detached, previously persistent and not associated with any session. Transient instances may be made persistent by calling save, persist, and or save or update. Persistent instances may be made transient by calling delete. Any instance returned by a get or load method is persistent. Detached instances may be made persistent by calling update, save or update, locked, or replicate. The state of a transient or detached instance may also be made persistent as a new persistent instance by calling merge, save, and persist methods result in an SQL insert, delete method in SQL delete, and update method or merge method in an SQL update. Changes to persistent instances are detached at flush time and also result in an SQL update. Save or update method and replicate method result in either an insert or an update. It is not intended that implementers be thread safe. Instead, each thread transaction should obtain its own instance from a SessionFactory. A session instance is serializable if its persistent classes are serializable. If the session throws an exception, the transaction must be rolled back and the session discarded. The internal state of the session might not be consistent with the database after the exception occurs. Here you can see session methods that make state transitions happen. An entity instance in our application appears in one of three main states in relation to the session persistence context. Transient. This transient isn't and never was attached to a session. This instance has no corresponding rows in the database. It's usually just a new object that we created to save to the database. Persistent. This instance is associated with a unique session object. Upon flushing the session to the database, this entity is guaranteed to have corresponding consistent record in the database. Detached. This instance was once attached to a session. In a persistent state, but now it's not. An instance entered this state if we evict it from context, clear or close the session, or put the instance through serialization, deserialization process. When the entity instance is in the persistent state, all the changes that we make to the mapped fields of this instance will be applied to the corresponding database records and fields upon flushing session. The persistent instance is online, whereas the detached instance is offline and not monitored for changes. This means that when we change the fields of a persistent object, we don't have to call save, update or any of those methods to get these changes to the database. All we need to do is commit the transaction, flush the transaction, or close the session. Persist. The persist method is intended to add a new entity instant to the persistent context. That is transitioning an instance from transient to persistent state. Save. The save method is an original Hibernate method that doesn't conform to the JPA specification. Its purpose is basically the same as persist, but it has different implementation details. The documentation for this method strictly states that it persists the instant, first assigning a generated identifier the method will return serializable value of this identifier. Merge. The main intention of the merge method is to update a persistent entity instance with new field values from the detached entity instance. For instance, suppose we have RESTful interface with the method for retrieving a JSON serialized object by its ID to the caller, and the method that receives an update version of this object from the caller. An entity that passed through such serialization, deserialization will appear in a detached state. After deserializing this entity instance, we need to get a persistent entity instance from a persistent context and update its field with new values from this detached instance. So the merge method does exactly that. Find an entity instance by ID taken from past object. Either an existing entity instance from the persistent context is retrieved, or a new instance loaded from database. Copies fields from the past object to the instance. Returns a newly updated instance. Update. As with persist and save, it's the update method is an original Hibernate method. Its semantics differ in several key points. It acts upon a past object. Its return type is void. The update method transitions the past object from detached to persistent state. This method throws an exception if the pass is in a if we pass it a transient entity. Save or update. This method appears only in Hibernate API and doesn't have its standardized counterpart similar to update. We can also use it for reattaching instances. Actually, the internal default update event listener class that processes the update method is a class of default save or update listener, just overriding some functionality. The main difference of the save or update method is that it doesn't throw an exception when we apply it to a transition instance. Instead, it makes it transient instance persistent. Here you can see a new is passed to transient, and transient interacts with persistent. Save persistent. Save persist. Save updates are from transient to persistent. Delete is from persistent to transient. Persistent object is inside in the session. Persistent interacts with detach, evict, and session.close are passed from persistent to detach. Locked update, merge, and save or update are passed from detach to persistent. Get, load, and SQL query are to persistent. We can consider this code segment as an example. SessionFactory in Hibernate 5 example here, and local SessionFactory bin is created here, and here you can see interface session. The main runtime interface between a Java application and Hibernate. This is the central API class abstracting the notion of a persistent service, and this is in org.hibernate package. Here we can consider this segment in hibernate.cfg.xml file. Here you can see set the current session context here, and you can see the property hibernate.current session context class here. Supply a custom strategy for scoping of the current session. Example JTA thread managed custom.class. As an example, we can consider as an exception example, we can consider session exception class thrown when the user calls a method of a session that is in an inappropriate state for the given call. For example, the session is closed or disconnected. This class is in org.hibernate package. As an example, we can consider this: no current session context configured, org.hibernate.implement.SessionFactory implement.get current session. Now we are focusing on transaction. Allows the application to define units of work while maintaining abstraction from the underlying transaction implementation. For example, JTA, JDBC. A transaction is associated with a session and it is usually instantiated by a call to a session.begin transaction method. A single transaction, a single session might span multiple transactions, since the notion of a session, a conversion between the application and the data store, is of course granularity than the notion of a transaction. However, it is intended that there be at most one uncommitted transaction associated with a particular session at any time. Implementers are not intended to be thread safe. Here you can see Hibernate transaction management example. A transaction simply represent a unit of work. In such case, if one step fails, the whole transaction fails, which is termed as atomicity. Transaction can be described by acid properties: atomicity, consistency, isolation, and durability. In Hibernate framework, we have transaction interface that defines the unit of work. It maintains abstraction from the transaction implementation, JTA, JDBC. The methods of transaction interface are follows. Void begin starts a new transaction. Void commit ends a unit of work unless we are in flush mode .never. Void rollback forces this transaction to roll back. Void set timeout int seconds. It sets the transaction timeout for any transaction started by subsequent call to begin on this instance. Boolean is alive checks if the transaction is still alive. Void register synchronization registers a user synchronization callback for this transaction. Boolean was committed, check if the transaction is committed successfully. Boolean was rollback, check if the transaction is rolled back successfully. As an example, we can consider this code here. Here you can see start transaction, here starts transaction, session.begin transaction here. Save the student object here and commit transaction here, transaction.commit, and rollback transaction if this exception occurred. And interface transaction allows the application to define units of work while maintaining abstraction from the underlying transaction implementation. For example, JTA, JDBC. This is in package org.hibernate. As an example too, we can consider jta.user transaction in hibernate.csg.xml. Hibernate transaction property jta.user transaction. A JNDI name used by JTA TransactionFactory to obtain the JTA user transaction from the application server. For example, JNDI /composite/name. As an exception example, we can consider class transaction exception. indicates that a transaction could not begin, committed, or rollback. This class is in org.hibernate package. Now we are focusing on JNDI, the Java naming and directory interface. JNDI is a Java API for a directory service that allows Java software clients to discover and look up data and resources in the form of Java objects via a name. Like all Java APIs that interface with host systems, JNDI is independent of the underlying implementation. Additionally, it specifies a service provider interface, SPI, that allows directory service implementations to be plugged into the framework. The information looked up via JNDI may be supplied by a server, a flat file, or a database. The choice is up to the implementation used. Here you can see the architecture of JNDI. JNDI architecture consists of an API and a service provider interface, SPI. Java applications use the JNDI API to access a variety of naming and directory services. The SPI enables a variety of naming and directory services to be plugged in transparently, thereby allowing the Java application using the JNDI API to access their services. The JNDI is included in the Java 2 SDK version 1.3 and later releases. It also available as a Java standard extension for use with the JDK 1.1 and the JDK and Java 2 SDK version 1.2. It extends the version 1.1 and version 1.2 platforms to provide naming and directory functionality. To use the JNDI, you must have the JNDI classes and one or more service providers. The Java 2 SDK version 1.3 includes 3 service providers for the following naming directory services. Lightweight Directory Access Protocol, LDAP, Common Object Request Broker Architecture, COBA, Common Object Services, COS Name Service, Java Remote Method Invocation, RMI Registry, other service providers can be downloaded from the JNDI website or obtained from other vendors. When using the JNDI as a standard extension on the JDK 1.1 and Java 2 SDK version 1.2, you must first download the JNDI classes and one or more service providers. JNDI is divided into 5 packages: javax.naming, javax.naming directory, javax.naming.event, javax.naming.ldap, javax.naming.spi. As an example, we can consider this code, this segment. The line cfg.build SessionFactory still has to be executed somewhere to get a SessionFactory into JNDI in JMX deployment. You can do this either in a static initializer block, like or you can deploy Hibernate as a managed service. Hibernate is distributed with org.hibernate.jmx.hibernate service for deployment on an application server with JMX capabilities such as JBoss AS. The actual deployment and configuration is vendor specific. Here is an example, JBoss dash service.xml for JBoss 4.0.x. This file is deployed in a directory called meta-inf and packaged in a jar file with the extension .sar service archive. You also need to package Hibernate, its required third-party libraries, your compiled persistent classes, as well as your mapping files in the same archive. Your enterprise beans, usually session beans, may be kept in their own jar file, but you may include this EJB jar file in the main service archive to get a single hot deployable unit. Consult the JBoss AS documentation for more information about JMX service and EJB deployment. Here you can see bind the Hibernate service to JNDI here. JNDI name and this one. This is JBoss-service XML for JBoss 4.0.x. As an example too, we can consider this. Here hibernate.connection.dataSource is data source JNDI name, and hibernate.jndi.url is URL of the JNDI provider, and hibernate.jndi.class of the JNDI initial context factory. Hibernate.connection.username is database user, and hibernate.connection.password is database user password. Design the hibernate.properties file. As an exception example, we can consider JNDI exception. An exception indicating trouble accessing JNDI. This class is in org.hibernate.engine.jndi package. As an error example, we can consider this not binding factory to JNDI, no JNDI name configured. Now we are focusing on JDBC, Java Database Connectivity. JDBC is an application programming interface API for the programming language Java, which defines how a client may access a database. It is a Java-based access technology used for Java database connectivity. It is part of the Java Standard Edition platform from Oracle Corporation. It provides methods to query and update data in a database and is oriented towards relational databases. A JDBC to ODBC bridge enables connections to any ODBC accessible data source in the Java Virtual Machine JVM host environment. Here you can see the role of JDBC. The most widely used interface to access relational database today is Microsoft ODBC API. ODBC performs similar tasks that of JDC, Java Development Connection, and yet JDBC is preferred due to following reasons. ODBC cannot be directly used with Java because it uses a C interface. Call from Java to native C code have a number of drawbacks in the security, implementation, robustness, and automatic portability of applications. ODBC makes use of pointers which have been totally removed from Java. ODBC mixes simple and advanced features together and has complex options for simple queries. But JDBC is designed to keep things simple while allowing advanced capabilities when required. JDBC API is a natural interface. It's a natural Java interface and is built on ODBC. JDBC contains some of the basic features of ODBC like XOpen, SQL call level interface. JDBC is to Java programs, and ODBC is to programs written in languages other than Java. ODBC is used between applications and JDBC is used by Java programmers to connect to databases. Here you can see Java application is connected to application interact with JDBC driver manager. Here you can see JDBC native bridge interacts with native driver DBMS specific. Native driver interacts with DBMS. Here JDBC ODBC bridge interacts with ODBC driver. ODBC driver interacts with DBMS. JDBC driver DBMS specific interacts with DBMS. JDBC middleware various DBMS interacts with DBMS. Here we can take this as an example. This is in the hibernate.properties file. Here you can see hibernate.connection.driver underscore class JDBC driver class, hibernate.connection.url JDBC URL, hibernate.connection.username database user, hibernate.connection.password database user password, hibernate.connection.pool underscore size maximum number of pooled connections. As example 2, we can consider this and this segment is in hibernate.cfg.xml. This is database connection settings. Hibernate.connection.driver underscore class JDBC driver class, hibernate.connection.url JDBC URL, hibernate.connection here connection.username database user, connection.password database user password, and connection.pooled underscore size maximum number of pooled connections. As an exception example, we can consider JDBC exception, wraps and SQL exception, indicates that an exception occurred during a JDBC call. This class is in org.hibernate package. As an error example, we can consider this JDBC exception on Hibernate data access, SQL exception for SQL state XX000 error code 0 could not extract result set. Nested exception is org.hibernate.exception.generic JDBC exception could not extract result set. This happened in JDBC exception on Hibernate data access. Now we are focusing on JTA, the Jakarta transactions. JTA, formerly Java Transaction API, one of the Jakarta EE APIs, enables distributed transactions to be done across multiple open XA resources in a Java environment. JTA was a specification developed on the Java community process as JSR 907. JTA provides for demarcation of transactions boundaries. Open XA API allowing resources to participate in transactions. Here you can see distributed transactions and the transaction manager. A distributed transaction is a transaction that accesses and updates data on two or more networked resources. These resources could consist of several different RDBMS housed on a single server, for example Oracle SQL Server and Sybase, or they could include several instances of a single type of database residing on a number of different servers. In any case, a distributed transaction involves coordination among the various resource managers. This coordination is the function of the transaction manager. The transaction manager is responsible for making the final decision either to commit or roll back any distributed transaction. A commit decision should lead to a successful transaction. Rollback leaves the data in the database unaltered. JTA specifies standard Java interface between the transaction manager and the other components in the distributed transaction: the application server, and the resource managers. This relationship is illustrated in this diagram. The numbered boxes around the transaction manager correspond to the three interface portions of JTA. 1. User transaction. The javax.transaction.userTransaction interface provides the application the ability to control transaction boundaries programmatically. The javax.transaction.userTransaction method starts a global transaction and associate the transaction with the calling thread. The two transaction manager. The javax.transaction.transaction manager interface allow the application server to control transaction boundaries on behalf of the application being managed. Number 3, XA resource. The java.transaction.xa resource interface is a Java mapping of the industry standard XA interface based on the Xopen CAE specification, distributed transaction processing, the Java XA specification. Notice that the critical link is support of the XA resource interface by the JDBC driver. The JDBC driver must support both normal JDBC interactions through the application or the application server, as well as the XA resource portion of JTA. Data Direct Connect for JDBC drivers provide the support. Developers of code at the application level should not be concerned about the details of distribution transaction management. This is the job of the distributed transaction infrastructure, the application server, the transaction manager, and the JDBC driver. The only caveat for application code is that it should not invoke method that would affect boundaries of the transaction while the connection is the scope of distributed transaction. Specifically, an application should not call the connection methods commit rollback and set auto commit true, because they would interfere with the infrastructure's management of the distributed transaction. Here you can see in JTA Java application is here, and application service here below. JDBC driver manager is there, and below that JDBC driver, and is connect and JTA connected to the database here. And the Java application is connected to transaction manager and JTA here. The one is user transaction, and 2 is transaction manager, and 3 is XA resource. We can consider this one as an example, JBoss transaction. This segment is in persistent.xml file. Here you can see a name attribute. Every entity manager must have a name, and transaction type attribute. Transaction type used either JTA or resource underscore local, default to JTA in an EE environment, and to resource underscore local in a Java SE environment. When this is when JTA dash data source is used, the default is JTA. If none dash JTA dash data source is used, resource underscore local is used. JTA and dash data dash source or none dash JTA dash data dash source. This is the JNDI name of where the javax.sql data source is located. If we use the SQL when running without a JNDI available data source, you must specify JDBC connection with Hibernate specific properties. Properties The properties element is used to specify vendor specific properties. This is where you will define your Hibernate specific configurations. This is also where you will have to specify JDBC connection information as well. As an example too, we can consider this one. Here, name attribute, every entity manager must have a name. Transaction type attribute, transaction type used either JTA or resource underscore local, default to JTA in a Java EE environment and to resource underscore local in a Java SE environment. When a JTA dash data source is used, the default is JTA. If none dash JTA dash data source is used, resource underscore local is used. Provider. The provider is a fully qualified class name of the EGB persistence provider. You do not have to define it if you do not work with several EGB3 implementation. This is needed when you are using multiple vendor implementation of EGB persistence. JTA dash data dash source, none dash JTA dash data dash source. This is the JNDI name of where the javax.sql.data source is located. When running without a JNDI variable, JNDI available data source, you must specify JDBC connections with Hibernate specific properties. Mapping file. The class element specifies the EJB3 compliant XML mapping file that you will map. The file has to be in the class path as per the EGB specification. Hibernate Entity Manager will try to load mapping file located in the jar file at meta_inf/orm.xml. Of course, any explicit mapping file will be loaded too. As a matter of fact, you can provide any XML file in the mapping file element. That is either HBM files or EJB3 deployment descriptor. Jar file. The jar file element specify a jar to analyze all property annotated class, annotated packages, and all HBM.xml files. Part of this jar file will be added to the persistence unit configuration. This element is mainly used in Java EE environment. Use of this one in Java SE should be considered as non-portable. In this case, an absolute URL is needed. You can alternatively point to a directory. This is especially useful when in your test environment the persistent.xml file is not under the same root directory or jar than your domain model. Class. The class element specify a fully qualified class name that you will map. Here, by default, all property annotated classes and all HBM.xml files found inside the archive are added to the persistent unit configuration. You can add some external entity through the class element though. As an extension to the specification, you can add a package name in the class element. For example, class org.hibernate. and close class tag. Caution: the package will include metadata defined in the package level, that is in package-info.java. It will not include all the classes of given package. And properties, the properties element is used to specify vendor specific properties. This is where you will define your Hibernate specific configurations. This is also where you will have to specify JDBC connection information as well. Example 3, you can see here bootstrapping Hibernate OGM using JPA. Example 4, we can consider bootstrapping Hibernate OGM using Hibernate ORM native APIs. Here, assuming you are using JTA in a non-content environment, and assuming JBoss Transaction Manager in standalone mode, assuming the default InfiniSpan settings, a dual annotated classes, build the SessionFactory. Except as an exception example, you can consider JTA platform inaccessible exception. Indicates problems accessing transaction manager or user transaction through the JTA platform. This exception is in this class is in org.hibernate.resource.transaction.backend.jta.internal package. As an error example, we can consider could not register synchronization with JTA transaction manager here. Now we are focusing on database. Database, also called electronic database, any collection of data or information that is specially organized for rapid search and retrieval by a computer. Databases are structured to facilitate the storage, retrieval, modification, and deletion of data in conjunction with various data processing operations. A database management system, DBMS, extracts information from the database in response to queries. Here you can see how Hibernate works. At the heart of every interaction between your code and the database lies the Hibernate session. The heart of any Hibernate application is in its configuration. There are two pieces of configuration required in any Hibernate application. One to create the database connection, and the other creates the object to table mapping. Here you can see .cfg.xml. This file is connected to Hibernate configuration for database 1. Loaded to create is passed from .cfg.xml file to Hibernate configuration data for database 1. Hibernate configuration for database 1 is connected to database 1, and here .cfg.xml is connected to class1 hmb.xml and other similar files. Here defines the database specific settings and groups, HBMs for a given database. .cfg.xml is connected to Hibernate configuration for database 2, and loaded to create is passed from .cfg to .cfg.xml to Hibernate configuration for database 2, and Hibernate configuration for database 2 is connected to database 2, and here work with multiple databases. And Hibernate configuration for database 2 is connected to factory, and configuration object is used to create here, and single factory is singleton per database, and factory is connected to session, and there's a bridge between among tables and classes and session. Here you can see Hibernate ORM and Hibernate OGM. If you take MongoDB as NoSQL database here, MongoDB does not require following ACID properties, and hence do not support the transaction. Hibernate OGM mitigate its lacking by queuing changes before committing them. Hibernate OGM also recommends using in transaction demarcation with no rollback option. Perhaps this is the reason why bootstrapping through JTA is suggested. Because of JPA is an inherently relational API, so be prepared for you to run into these aspects. First, JPA is not supporting a plethora of the features MongoDB exposes: geopartial functionality, upserts, etc. You are going to need a custom extension for that, in which minimizes the benefit of using JPA in the first place. And number two, a plethora of stuff available in JPA doesn't make any sense in MongoDB non-relational world, and won't be supported transactions. What's a join column supports supposed to be in MongoDB? The former not bring available a pretty dangerous actually. What's supposed to happen if a JPA developer calls transaction.rollback? Strictly speaking, you can't implement JPA 100% by definition, and most of the self-proclaimed JPA implementations for NoSQL are basically providing a tiny subset of JPA. Some of the annotations for mapping some of the entity managed API. And number three, simply switching the store behind an object model is fallacy to, especially NoSQL stores are built in a way to favor certain data structures. MongoDB is good for documents. Neo4j is highly interconnected data. That means that you will model the domain code and the converters differently based on what you store you actually use. Switching stores arbitrarily will lead you to reduce your domain model to a least common denominator and basically make less use of the features that you select the store in the first place. Here you can see Hibernate ORM here and application, then Hibernate ORM, then JNDI, JDBC layer, JTA, and these are interact with SQL database, and SQL statements are passed to SQL database, and results from SQL database. Here you can see Hibernate OGM application, Hibernate ORM, Hibernate OGM, data store provider, grid dialect, and these are interacting with NoSQL database. Here you can see the general architecture of Hibernate OGM. Hibernate OGM is really made possible by the reuse of a few key components. Hibernate ORM for JPA support, Hibernate's search for indexing and query purposes, the NoSQL drivers to interact with underlying data store, Infinispans using directory to store indexes in Infinispan itself or in many other NoSQL using Infinispans right through cache stores, Hibernate OGM itself. Hibernate OGM reuses as much as possible from Hibernate ORM infrastructure. There's no need to rewrite an entirely new JPA engine. Persisters and loaders two interfaces used by Hibernate ORM have been rewritten to persist data in the NoSQL store. This implementation are the core of Hibernate OGM. The particulars between NoSQL stores are abstracted by the notion of data store provider and data grid. Data store provider abstracts how to start and maintain a connection between Hibernate OGM and the data store. Grid dialect abstract how itself, including association, is persisted. Other than these, all the create, read, update, delete, CRUD operations are implemented by the Hibernate ORM engine. Object hydration and dehydration, cascading, lifecycle, etc. As if today 4 data store providers are implemented: a map based data store provider for testing, an Infinispan based data store provider for persist your entities in Infinispan, Encache based data store provider to persist your entities in Encache, a MongoDB based data store provider to persist data in a MongoDB database. To implement JPQL queries, Hibernate OGM passes the JPQL string and calls the appropriate translator functions to build a native query. If the query is too complex, the native capabilities of the NoSQL store, the tied query engine is used as the an intermediary engine to implement the missing features, typically joins between entities aggregation. Finally, if the underlying engine does not have any query support, Hibernate Search is used as an external query engine. Hibernate OGM best work in a JTA environment. The easiest solution is to deploy it on a Java EE container. Alternatively, you can use a standalone JDBC transaction manager. Here you can see application. Object model is inside the application, and application is connected to JPA or Hibernate native APIs, and it's interact with JPA or Hibernate native APIs. JPA or Hibernate native API, Hibernate Core, Hibernate ORM Core, Hibernate OGM Core, data store provider, and grid dialect query engine are in Hibernate OGM. JPA or Hibernate native APIs are connected to Hibernate ORM Core. Basically, they are interacting with ORM, Hibernate ORM Core, and Hibernate ORM Core is connected to Hibernate OGM Core. Delegates persistence load queries to Hibernate OGM Core. Hibernate OGM Core delegates data store CRUD operations to data store provider and grid dialect. Data store provider and grid dialect interacts with data store here with NoSQL data store. Hibernate OGM Core delegates queries to JPQL parser. JPQL parser, data store query translator, and tied query engine and connectors are inside query engine. And JPQL parser delegates simple queries to data store query translator. JPQL parser delegates complex queries to tied query engine and connectors. Tied query engine and connectors transform in a simpler data store supported queries to data store query translator. Data store query translator executes native queries, and it is connected to SQL data store. As an example, we can configure the database connection. This segment is from hibernate.cfg.xml. To create a connection to a database, Hibernate must know the details of our database tables, classes, and other mechanics. This information is ideally provided as XML file, usually named hibernate.cfg.xml, or as a simple text file with name value pairs, usually named hibernate.properties. Here connection URL indicates the URL to which we should be connected, and driver underscore class represent the relevant driver class to make the connection, and dialect indicates which database dialect we are using. MySQL in this case, and if you are following the hibernate.properties file approach, note that all the properties are prefixed with hibernate and follow pattern hibernate asterisk properties, for instance. We can consider this one as example 2 for Hibernate OGM. This is in persistent.xml. So here we have to define data store details in Hibernate persistent.xml. the value of the attribute transaction-type as an JTA. This implies that we want a JTA entity manager from the entity manager factory, and provider, which is Hibernate OGM persistence for Hibernate OGM. Additional details related to DB. These typically vary between different data sources. The configuration assumes MongoDB is running and accessible on defaults. If this is not the case, we can always provide details as necessary. And as an example 3, we can consider this one in hibernate.properties file. Here hibernate.connection.ur indicates the URL to which we should be connected. Driver class represents the relevant driver class to make a connection, and the dialect indicates which database dialect we are using, MySQL in this case. If you are following the hibernate.properties file approach, note that all the properties are prefixed with Hibernate, and follow a pattern hibernate.*properties for instance. As an example 4, we can consider this code segment. Here the class configuration. An instance of a configuration allows the application to specify properties and mapping documents to be used when creating a session factory. Usually an application will create a single configuration, build a single instance of session factory, and then instantiate sessions in a thread servicing client requests. The configuration is meant only as a initialization time object. Session factories are immutable and do not retain any association back to the configuration. The class configuration is in org.hibernate.cfg. As an example, we can consider this caused by java.sql exception ORA-12899, value too large for column JBPM dot case fields dialog dot item value. As an error example, we can consider this could not get list of tables from database, probably a JDBC driver problem. This is the end of my presentation. Thank you very much for watching it.